In the United States, and I assume also in Italy, fertilization with liquid fertilizers, foliar fertilization has become a very common practice, especially on high maintenance turf sites, golf course putting greens, golf course tees and fairways, and also athletic fields. And so we've been doing some research in this area for the last almost 10 years, trying to understand the process a little bit more from a scientific standpoint. So what I would like to do today is start off with maybe just some terminology that I think sometimes is confused when we're talking about foliar fertilization, especially relative again to nitrogen. And then I want to spend some time talking about some of the science behind foliar uptake, or the uptake of nitrogen through the leaves of plants, which is very different from what is normally done by the root system. And then finally, I want to discuss just some management practices that you should be considering when you're using foliar fertilization, just to make sure that you're getting the most out of that practice, that it's working as efficiently as possible on your golf course. Okay, so when I talk to golf course superintendents in the States about foliar fertilization, oftentimes I get a range of questions relative to terminology. And these are some of the ones that I might see. Are liquid and soluble fertilizers, is that the same thing? Can granular fertilizers be soluble? And can they be the same thing? Can both liquid and granular fertilizers be soluble? Okay, so can you use both of those types of products? Are liquid fertilizers more precise for applying fertilizers than granular fertilizers? And again, many of the products that you have available to you come in a liquid form. So are those products more precise or more efficient at applying fertilizers than are granular fertilizers? And then finally, can you use liquid fertilizers or granular fertilizers for foliar fertilization? Are both of those products suitable for feeding grasses through the leaves? So we'll start by just discussing some of these questions to try to make sure we have the same terminology and have the terminology correct. Okay, so let's start with a granular fertilizer. So granular fertilizers, you can see over here on the left, on the right. And basically a granular fertilizer just refers to a dry formulation, okay? And so this can come in many forms, but it's just a dry formulation of fertilizer. So it can come in various sizes. You can see a smaller size fertilizer, smaller prills here, larger prills, larger fertilizer sizes here. It can be either crystals like you see here, or it can be a powder, okay, very fine material. It can be very uniform or homogeneous. Again, like the urea here, it's a very uniform product. Or it can be non-homogeneous or non-uniform, like you see with this product in the top. So different types of materials in the same product, like a complete fertilizer. In most cases, granular fertilizers have some solubility in water, so they can be dissolved in water, but they vary in terms of how soluble they might be when you try to put them in solution. So for example, if we look at some of these common granular fertilizers that you might see, again, ammonium nitrate, urea, ammonium sulfate, and on down the line there's some potassium sources, phosphorus sources. You can see that this is the solubility of these. This is in pounds per 100 gallons. I think that's right. You have pounds in 100 gallons. Some products, such as the ones here at the top, are very soluble. Things like nitrate of ammonia, urea, sulfate of ammonia, very easily dissolved in water. Other products, like some of these things like sulfate of potash, very low solubility. So they're not going to be as easily dissolved in a solution as some of these other nitrogen sources. Okay, so again, you can have multiple types of fertilizers that can be considered soluble fertilizers. Things that are fine granulars, like the one over here on the left, the Miracle-Gro product. Seppi, do you have products like this in Italy? Yeah, the powder products, okay. Urea, and then maybe a professional product such as the one you see here. It's a complete fertilizer, but again, designed to be very soluble in water. Now, the reason I'm spending a lot of time talking about solubility in water is that when you start looking at foliar fertilization, it's the most important characteristic. The fertilizer has to be dissolved in the water before it can be taken up by the leaves of the plant. Okay, so you need something that has a very high solubility. Okay, that will dissolve very easily. Okay, let's go to the next slide. Okay, what about liquid fertilizers? Okay, fertilizers, they come already in a solution. Now, most of these fertilizers can either be a clear liquid, like you see here, okay, very uniform liquid material, or they could be a suspension. Okay, so the material is a little more heavy or viscous. Is there an Italian word for viscous? Is that good? Viscoso. Okay, so it's they're not going to be a clear solution, but the materials, once they're dissolved in a larger volume of water, will then become more soluble. So many of the fertilizer products that you see in the golf industry especially are going to usually be probably in this form, maybe a little more of a suspension type fertilizer. But again, they're in a liquid formulation that once they're added to a higher volume of water, then they easily dissolve in that water. And again, these are primarily the types of fertilizers you see in the golf market and high maintenance type situations. Okay, so again, when we're talking about something for foliar fertilization, the most important thing is that it's soluble. Okay, and again, it doesn't really matter if it's a granular material that you start off with that you're going to solubilize, or if it's a liquid material. In order for it to be effectively used for foliar fertilization, it has to be dissolved in water before it can be useful for that. Okay. All right, so the next term I want to introduce is the term of foliar feeding. Okay. In foliar feeding, we are basically at that point trying to introduce plant nutrients into the leaves of the plant. Okay, and so maybe I ask a question or two. So when you are applying foliar fertilizers to your turf, do you let the solutions stay on the leaves, or should you irrigate it first? Stay on the leaves. Anybody else like to irrigate theirs right after they spray it? Good. Then you're doing it correctly. In order for it to be taken up by the leaves, it needs to stay on the leaf surface as long as possible and stay really in solution as long as possible. Once it dries on the leaf surface, that solution dries, then it's not going to be taken up by the leaves very easily after that. It could be redissolved, maybe by dew or by moisture, but usually it's not going to be dissolved once it dries onto the surface of the leaf. So again, very important that the solution stays on the leaves for foliar uptake. Okay, so we have three different kinds of fertilizers here. Again, this is a complete fertilizer in a granular but more of a fine powder form. We have a liquid formulation like we talked about a minute ago. And then we have urea down here, which is a granular, again, kind of an agricultural grade fertilizer. So the question is, can these fertilizers all be used for foliar fertilization? Everybody, I'm getting blank stares. Clear as mud. The answer is yes, they can all be used for foliar fertilization. Again, as long as that fertilizer can be dissolved in water and stay in solution, it can be taken up by the leaves as that solution. So one of the things that I hope you leave with today is that there are many options available to you for foliar fertilization. Okay, it's not just a packaged liquid formulation. You can use many different types of fertilizers for foliar feeding. And sometimes it's very important to look at those because, as we'll see later on, there's significant cost differences between some of these foliar products. And so if you're going to use a foliar fertilization on maybe an area like your fairways, where you have a large area, not as important as your greens, maybe a lower grade or lower cost fertilizer would be more appropriate there. And then maybe on your greens you use something that's maybe a higher grade foliar fertilizer. Okay. Any questions? Okay, so why do golf course superintendents use foliar fertilization, especially on putting greens? And we did some work in Arkansas where we surveyed and asked the golf course superintendents, how much of your fertilizer do you put out as foliar? And some superintendents were putting out as much as 50 to 75% of their fertilizer as foliar fertilization, which I think is quite high, but it was still, that was what they were doing. So why would you use foliar fertilization that much? Well, I think the main reason, at least in the States, that people use foliar fertilization so much and so heavily is that in the States we spray probably a lot more than you do in Italy. Every week the sprayer is going out to spray the greens. It's either spraying a wetting agent or a fungicide or an insecticide or something. And so the superintendent will use that opportunity to add some fertilizer to the solution and spray some fertilizer. So they're using the sprayer quite a bit, and so it's an easy way to deliver fertilizer in a very precise form. And that's another thing that I think is important, is that because you can calibrate the sprayer much more precisely than you can calibrate your spreader, you can put fertilizers out in a much more accurate form than you can with a dry material. So I think that's one of the main reasons that superintendents use it quite a bit. A second thing, again on putting greens especially, is that they want to have very consistent growth. Okay, they don't want ups and downs of growth on the greens because green speed is so important, just like it's important here in Italy. Okay, you want to have consistent growth, fast green speeds, and foliar fertilization allows it. And I'm going to show you some data here in just a minute to kind of demonstrate that fact. It can also be very useful when you're trying to provide nutrients when maybe the root system is not working efficiently. And certainly in our part of the United States, during the heat of the summer, our bentgrass or our coannular greens, the root systems get very compromised, get very shallow. The root system has a hard time taking up water, taking up nutrients. And so foliar fertilization is a way to deliver nutrients without depending on an active root system. Okay, so that can be an important part of why you might use foliar fertilization. Many foliar fertilization products also have other benefits. Maybe they are micronutrients, maybe they are biostimulants, hormones that the plants need. And so again, foliar fertilization can be a way to deliver not just the nutrient, but also some other beneficial components that the turf might need, especially during stressful periods. Increased uptake efficiency. Do I have that right there? That's correct. Increased uptake efficiency. I'm going to show you some data in a little while that foliar fertilization and foliar uptake of nutrients is actually much more efficient than root uptake of nutrients in terms of how much of the nutrient you apply that can be absorbed by the plant. And so from an efficiency standpoint and an environmental standpoint, that can be very useful, that you can get maximum uptake of the nutrients that you apply. And then again, finally, because of this increased efficiency, next slide please, you can also have improved environmental safety. Okay? So again, for areas where you're concerned about nutrient runoff, nutrient movement, this can be also very important. Okay, so as I mentioned, one of the reasons that frequent foliar fertilization, or what a term we call spoon feeding, at a very small dose at a time, can provide more consistent growth, especially on putting greens, compared to infrequent applications of fertilizers through the roots. How many of you use the step meter to measure your green speeds? 1? 2? Okay, we've got a few parts. Right, so again, in the United States, it's very common that the superintendent constantly needs to know, what are my green speeds? Are they changing? Are they getting faster or slower? And trying to make modifications. And then many management practices are also being used, such as rolling, to constantly improve and increase putting green speeds. Okay, it's very important. It's the #1 issue for golf course superintendents: putting green quality, putting green speed. Now, this was a study that a colleague at North Carolina State did, Dan Bowman. It was a very simple study, but it demonstrated, I think, an important reason for foliar fertilization, or for small feeding of nutrients frequently. So what Dr. Bowman did was he took a fertilizer and he applied it. This was 5 grams of nitrogen per meter squared. And he applied it every month. So he applied it once, and then 30 days later, applied it again, 30 days later, applied it again. So he basically saw the growth of the grass. We're looking at growth rate. The growth increased significantly, and then once the fertilizer was depleted, it started decreasing. And then increased again and decreased. So as you might expect, up and down in terms of the growth of the turf. He took the same amount of fertilizer and then put it out every, go to the next one, put it out every 2 weeks. Okay, so the same amount, but half as much on a 2-week schedule. And you can still see some increases and decreases in growth, but it's getting a little more consistent. Then he also applied it on a 1-week schedule. The color, I'm sorry, has changed here a little bit. So 1 week, you can see a little bit of growth, but now we're starting to see very consistent growth of the grass. Every day, the grass is growing about the same speed. And then finally, just to really prove his point, he put the turf out, or put the fertilizer out every day. Okay, so a fraction of the same amount of fertilizer, but every day he applied it. And now you can see the grass was growing the same basically over the entire study. So the growth rate becomes very consistent. So again, excuse me. This demonstrates that if you frequently feed your turf with smaller doses, the growth rate of the grass is going to be much more consistent, and your green speeds are likely going to be much more consistent from day to day, week to week, month to month, because of that frequency of feeding. Okay, some other things about nutrient uptake. Okay, one of the things that is very important for all of us to remember is that grasses weren't really designed to take up nutrients through the leaves. Okay, they have this thing called a root system for a reason. Okay, that root system is there to take up water, to take up nutrients from the soil, and it has a much higher capacity for taking up nutrients than the leaves do. And so there are going to be many times when you need to continue to use granular feeding through the roots because you need to get higher amounts of fertilizer into the turf at one time. For example, when you're aerifying or cultivating your greens and you need to recover those greens very quickly from cultivation, you need to add enough nutrients through the root system so that plant can really have all the nutrients it needs to be able to grow. So again, don't forget about the root system. Again, I think too many superintendents in the States have gone too much to foliar fertilization, and sometimes they forget that this root system is there to provide a lot of nutrients at given times. Okay, the other thing that's important to know is that some of the nutrients that plants need, and some of the nutrients that turf grasses need, can only be moved in the plant to where that plant needs it if they're taken out by the roots. And this is a very important point. We're going to talk about this a little more in just a second. But not all nutrients can move freely in the plant, okay, up and down in the plant. And so, in some cases, certain nutrients need to be taken up by the roots in order that they can get moved to where they need to be in the plant. Okay, so if we're talking about foliar fertilization, how do those nutrients get into the plant? Okay, if we put a nutrient solution on the leaves, what's the entryway that those nutrients get into the plant? Well, it's been assumed for a long time that there were two ways that nutrients could go into the leaves. Okay, one was through the stomata, okay, the little pores on the leaf surface where photosynthesis and transpiration occur. And then the other way is through the cuticle of the plant, which is the waxy surface on the leaf. Okay, so the entire surface is covered with a wax, and then the stomata are pores in the wax that allow gas exchange and things to move in and out of the leaf. So we had a question about this as to whether it was either the stomata or the cuticle. So we did one little study, again, a very simple study, where we sprayed a nutrient solution on the leaves, either at 10 o'clock at night or at 8 o'clock in the morning. Okay, so the idea here is that at 10 o'clock at night, the stomata, the pores, are closed. Okay, so no transpiration and photosynthesis occurring, so those pores are closed. And then in the morning, when we spray this at 8 a.m., the pores would be fully open. And what we found in two different trials was that there was really no difference between whether we sprayed it at night or we sprayed it during the day. So this is night application and day application. Okay, so what does this tell us? I'm going to make you answer a question. It kills me. You're not a super. You was right. Okay.
You need that's a little in the night.
Okay. That's a good guess, but it's not quite right. Somebody else want to guess? If there's no difference between spraying it at night and spraying it during the day, how is the nutrient getting into the leaf? Is it going through the stomata?
No.
I'm going to need a translation. You can maybe go through the cells, through the wax. Yeah, that's exactly right. Basically what this tells us is the stomata being open or closed, it doesn't matter. Okay, the same amount of nutrient goes in. So most of the nutrient is being absorbed through the cuticle wax. Okay? And if you look at the wax on these plants, this is a bent grass leaf here. You can see this very dark band here is the cuticle boundary, the cuticle layer, and then this is the stomatal opening here. And one of the things that's very interesting, both with the bent grass as well as with this is cynodon, Bermuda grass, is that the waxy layer actually doesn't just stop when it gets to the cuticle or gets to the stomatal pore. It actually continues inside of the stomatal pore and actually goes all the way inside this opening. So even if a nutrient goes through the stomata, it eventually still has to cross the cuticle layer to get into the plant. So the reason I bring this topic up is that you may hear from fertilizer salesmen that we have a nutrient that is absorbed through the wax, but it's not through the cuticle, or I'm sorry, not through the stomata. Or somebody says, well, that fertilizer is only absorbed through the stomata. Most of the research that I've seen on foliar uptake would suggest that the stomata have very little to do with it. So it's all going to be absorbed through the cuticle. So I bring that up just so when you hear people talk about these things, you'll understand stomatal entry of nutrients is very, very minimal. Okay? Primarily through the cuticle. Okay, so what nutrients can be taken up through the leaves of plants? All of our macronutrients, nitrogen, phosphorus, potassium, can all be absorbed through the leaves by foliar fertilization. Nitrogen and potassium are absorbed better because they're more easily dissolved in solution. Okay? If you have a phosphorus form that's readily dissolved and readily soluble, it can also be taken up, but the uptake is not quite as good on phosphorus as it is on nitrogen and potassium. Micronutrients such as zinc, iron, boron, I'm sure I've got these right here, sulfur, okay, sulfur, I've got nothing wrong, okay, very commonly used as foliar fertilizer. But most of these micronutrients are going to be chelated. Okay, is there a Italian word for that? Is that chelation? That's okay? Okay, chelation. So again, the main reason for chelation is to make these more soluble, make them dissolve in water better. But again, all of these can be taken up through the leaves. Okay, what about some of these nutrients? Calcium, silica, manganese, magnesium. Do you think they can be taken up through the leaves as foliar fertilization? Actually, they can. All of these nutrients can be absorbed by the leaves. Okay? But the important thing to remember is that getting the nutrient absorbed is not the end of the story. Okay? Once the nutrient is in the plant, then it has to move to parts of the plant where it's needed. So I'm going to talk a little bit about some basic botany. Okay? When we look at a cross-section of a grass leaf, okay, you got the leaf surface here, and then we have these bundles in here that are called vascular bundles. Okay? And inside the vascular bundles, you have two types of tissue. The xylem, which you see here, which causes things to go up in the plant, water and nutrients to go up. And then we have the phloem, which you see here, and it actually causes nutrients to go up or down, primarily down in the plant. Okay, but you can get some upward movement through the phloem as well. Now, it's important to know that these two types of tissues are not the same. Okay, so if we look at a xylem vessel here on the left, and then this is a phloem vessel here on the right. Okay, first let's talk about the xylem vessel. Okay, perfect. Basically, xylem vessels are like empty pipes. Okay, if you think about your irrigation pipe, that's what a xylem vessel is like. It's a non-living cell once it's produced, and so it's just a hollow pipe that water and nutrients can flow through, basically by mass transport. So if the nutrients are dissolved in the water in the soil, taken up by the roots, they're carried in the xylem very easily. Okay? Phloem tissue, on the other hand, is a little bit different. Phloem tissue is actually live cells. Okay? And phloem tissue, in order for things to move, it has to be loaded into the cell and then transported and then unloaded from the cell. So there are only specific types of nutrients and compounds that can be loaded and unloaded into phloem tissue. Okay? So if we are talking about movement of nutrients in the xylem or phloem, next slide please. Thank you. So basically the xylem, all nutrients can be moved through the xylem. Okay? Because again, they're hollow tubes that anything that gets dissolved in water can be carried in the xylem. Phloem, on the other hand, next slide please. We have differences in terms of mobility of nutrients through the phloem. Certain nutrients like sugars, carbohydrates, amino acids, potassium, phosphorus, and some others are highly mobile in the phloem. Okay, so that means the phloem can move those nutrients very easily. We have other nutrients that have what we call, we would say, intermediate mobility. They can be moved a little bit in the phloem, but not highly mobile. Okay, things like iron, zinc, some of the other micronutrients. And then we have certain nutrients that are immobile in the phloem. That means they can't be moved in the phloem of the plant. And two that I've got here listed are two very important ones, are calcium and silica. Okay? So if we are putting the solution on the leaves of the plant, and that nutrient is needed somewhere farther down the plant, and it's not mobile in the phloem, then you're not going to get movement of that nutrient to where it's needed. Okay, so I'm going to talk a little bit about calcium because I think, how many people spray calcium on the leaves? We have superintendents that use foliar calcium, and you can admit it. I have people that admit it all the time. So it's common in the States. A lot of people spray foliar calcium. To me, it makes no sense. Okay? If we look at where calcium is needed, calcium is mainly needed for cellular division. Okay, that's the primary function of calcium in plants, is for cell walls to be built during cell division. And so if we look at a turf grass, a putting green here, cell division is occurring right here near the crowns or the stolons of the plant, and then it's also occurring here at the root tip. Okay? So if we're applying a solution of calcium to the leaves, and that calcium is not mobile in the phloem, can't move down in the phloem, then basically calcium is not going to get to those points where it's most highly needed. Okay? So again, just always remember that, is that if you're going to put something on the leaves, you just want to make sure that that nutrient not only can get absorbed by the leaves, but then get translocated to where you need it in the plant. Now, I don't disagree with calcium fertilization. Okay, calcium fertilization is fine, but what should you be doing if you need to feed calcium? Where should you be putting it? Probably down here in the soil. Okay, where the calcium can be taken up by the roots, moved by the roots, taken to where it's needed in the plant for cell division. Okay? So again, just remember that. When you're using certain nutrients that can't be moved in the flow, and if we go back, can we go back one slide? Yeah. Just remember, any of these nutrients that aren't highly mobile in the phloem most likely would be better to be delivered through the roots, okay, into the soil. All right? Okay. Maybe we stop and see if there's a question. Very clear, I can tell. Okay, if there's no questions, I'll continue. Okay, so now let's spend some time talking about some recent studies that we've been doing at Arkansas on foliar fertilization, especially for putting greens. Okay, next slide. Okay, I had a graduate student, his name was Chris Stiegler, and he did a very large study on foliar fertilization, and his main objectives were to determine if the season of the year affected how foliar nutrition was working, if during certain parts of the year foliar fertilization was more efficient or less efficient. That was one question that he wanted to answer. Do different sources of nitrogen behave differently when they're applied to leaves? Do you get different amounts of uptake based on the type of nitrogen you're using? And then finally, is the nitrogen, if you apply nitrogen to the leaves of the plant, is that nitrogen potentially lost due to volatilization, basically volatilized back into the atmosphere after application? We have a number of publications on this work, so if any of you are interested after today, I'd be happy to send you some of our publications. Some of those are in USGA and others are in more scientific publications, but I'd be happy to send you those papers if you're interested in reading about it. Okay, so he had one study that was done on two different grasses. Pin A1 creeping bed grass and tip eagle Bermuda grass. Do we have Bermuda grass growers here? Any Bermuda grass greens? No Bermuda grass greens, just fairways and tees? Okay. I'm not going to talk about the Bermuda grass data, but if they did, I would try to answer that. We basically use two rates of nitrogen, either 0.5 or 1.25 grams of nitrogen per meter squared for our rates of nitrogen application. The nitrogen source that we used was urea, and then that urea was enriched with another form of nitrogen. It's called N15. It's a heavier isotope of nitrogen that allows us to accurately measure how much nitrogen was taken up by the leaves. So it's a common tracer that's used in nitrogen fertilization studies. The measurements that we did was we did a sequential measurement of nitrogen uptake. So we measured how much nitrogen was in the plant before we applied it, and then at 1 hour, 4 hours, 8 hours, and 24 hours after application, we took samples and measured how much of the nitrogen had been absorbed by the leaves. We basically measured, again, the tissue nitrogen using the N15 method, and then we also looked at volatilization of that nitrogen over a 24-hour period. How much total nitrogen was volatilized or lost from the tissue in 24 hours. Okay, so let's start with some questions. Okay, first question, how much of the foliar applied nitrogen gets into the leaf tissue, and how quickly does that happen? Okay, so this particular graph, what we're looking at across the bottom here, this is time after we applied the nitrogen. Okay, so this was at 0, this is 1 hour, 4 hours, 8 hours, and 24 hours after application. We measured how much nitrogen had been taken up by the plant. And what we're measuring here, this is percentage of applied nitrogen. Okay, so if we put out 0.5 grams of nitrogen per meter square, we're measuring what percentage of that was taken up by the plant. So if all of it was taken up, it would be at 100%. Okay, so if we got all half of that gram taken up, it would be at 100%. Okay, I just want to focus here on the two lines at the top on each graph. Okay, the blue line represents the lower rate of nitrogen, 0.5 grams per meter squared. The black line represents the higher rate of nitrogen, 1.25 grams per meter squared. And then this is just 3 of the months that we were doing. Again, one of the questions was, does month of the year affect foliar uptake? Okay, so these are 3 of the months in one of the seasons. I didn't put all the data here because it wasn't necessary. Okay, so some key things that we learned from just this particular graph and this data. Okay. The first thing, back one, right there, perfect. Basically what we always saw, regardless of the species of grass and the time of the year, was that generally absorption peaked by about 4 hours after application. Occasionally we might see a little more of the nitrogen be absorbed, but the point is that nitrogen absorption through the leaves is very rapid. Usually by 1 hour or 4 hours after we applied the nitrogen, a high percentage of that nitrogen that was going to be absorbed was absorbed. Okay? So again, if you continue out here to 24 hours, you might get a little more of the nitrogen taken up. But in most cases, the line starts getting flat once we get to about 4 hours. Okay, what does this mean for you? Well, what this means for you is that if you need to apply irrigation, if you need to do something else to the turf, usually if you can let the solution sit on the leaves for 4 hours, you're probably going to have most of the uptake that you're going to get. So waiting longer, waiting 24 hours, you're probably not going to gain much by waiting 24 hours. Okay, so that's an important point. Okay, the next slide. Okay, this may be a little hard to see. The lines didn't come across here very well. So the numbers here too? Oh yeah, we've got the numbers here. Okay, you were fine. That was good. Perfect, right there. Okay, so this is a line that just kind of shows the maximum absorption. You can't see it, I apologize, it's in white here. But basically, if you look at these 3 months, we got about 85% absorbed in May, 70% in June, 60% in July. So we generally got pretty high uptake efficiency of the applied nitrogen. Now, you may look at this data and say, well, I would think that it would be higher than that. 60 or 70%, what about the other 30%? Why did you lose that? Well, if you look at research from soil applied nitrogen where you put the nitrogen down in the soil and measure uptake efficiency, in most cases, 40 or 50% uptake would be considered very high. Okay? So comparing foliar fertilization to soil fertilization, these uptake efficiencies are actually much higher than you would ever get with soil application of nitrogen. So again, the uptake efficiency is very good with foliar fertilization. In most cases, if we had this nitrogen on the surface of the plant, let's look at this one here where we maybe weren't quite as high. We get 60% of the nitrogen taken up in the first 24 hours. Okay? And let's say somewhere at this point, we decide to irrigate the turf. All right? So any of the nitrogen that's still on the leaves most likely is going to be washed from the leaves and then probably taken up very quickly by the surface roots. So if you look at total uptake of nitrogen, these numbers would probably be even higher because some of that nitrogen that was still on the leaves probably is eventually taken up by the roots. Okay? So again, comparing this to just soil applied nitrogen, the uptake efficiency is very high. And so, again, I'm not sure all of the rules and regulations in Italy about environmental fate of nutrients, but in many parts of the states, this is a very important issue now. And so, superintendents are using more foliar fertilization even in areas outside of their greens where they're concerned about nutrient loss into waterways, lakes, streams, wherever. So it's it's a very good way to show that you have the highest potential uptake efficiency, which means the lowest potential for environmental loss. Okay? Okay, the next question was how much of the nitrogen is volatilized into the atmosphere? Again, for many years we thought that volatilization might have been a potential loss mechanism where some of that nitrogen would be lost back into the atmosphere after applying it. So, again, if you look at soil applied nitrogen studies, okay, from turf, in many cases you can get up to maybe 20% of the applied nitrogen when you put it into the soil lost due to volatilization. And these were generally longer term studies, maybe for a month or two compared to what we were doing. But again, over time, the nitrogen that's in the soil is susceptible to being lost due to volatilization. So we wanted to think about how is this compared to foliar fertilization. Okay, so we used a little trapping system here. So as soon as we put the nitrogen on the turf, we put this chamber on the turf, and any nitrogen that gets evolved or it gets volatilized into the atmosphere gets trapped in a little acid bath here. Okay, and we can determine how much nitrogen is in there back in the laboratory with the titration. So again, if you look at some of the data here, this is creeping bent grass on the bottom, Bermuda grass on the top. Again, we had 2 rates of nitrogen. The triangle is 0.5 gram per meter square, and the circle is 1.25 grams per meter square. And what we're looking at here are different months in a growing season. Okay? And so what we saw on creeping bent grass, it really didn't matter which month it was. We had very low percentages of the nitrogen being lost due to volatilization. Usually less than 1%, sometimes maybe 1.5%. Very, very low levels. Bermuda grass, we occasionally had a little higher rates of volatilization, but numbers like this was primarily during the period when the Bermuda grass was still coming out of dormancy and it couldn't maybe quickly absorb that nitrogen. So basically what we found was that the mean was only about 2% over a couple of years of studies for Bermuda grass and about 0.5% for creeping bent grass. So volatilization losses in nitrogen are actually quite low, which is good. Again, it's another signal that it's an efficient system. We're not losing a lot to some of these other potential environmental effects. Occasionally we saw higher rates of volatilization on Bermuda grass with a higher rate of nitrogen, which is what you would expect. More nitrogen is there, more could potentially be volatilized. And my last one, Again, suggesting minimal losses of nitrogen when you use foliar fertilization revitalization. Okay. Question? Stop. Answer a question. We have to. American superintendents usually ask more questions. Yes.
Pronto? Allora, se nell'assorbimento foliare cresce il pH,
Does the pH of the solution affect uptake?
è il quantitativo d'acqua terrestre?
It does. I don't have any data that I can present you guys. There has been some research that has shown that especially high pH water can cause a decrease in foliar uptake. And mostly because of solubility issues. Okay? When the pH of the water gets too high, some of the nutrients that are in there will precipitate or become insoluble, and then once they're insoluble, they can't be taken up by the leaves. So it is one of the advantages of some of the formulated fertilizer products that are out there, especially the liquid formulations, is that they have a buffering agent that basically makes the pH be more neutral, even if you've got higher pH water. Do you have very high pH water, or is that most of your waters, or what kind of pH are we talking about? 7.5, 8? Yeah, I would say that if you're above 7.5, especially if you're above 8, you might want to consider using some type of acidifying agent to try to bring the pH of that water down. Giuseppe, I assume some of your foliar fertilizers are buffered so that they'll bring the pH down. So that's pretty common, and that's a nice thing about some of the formulated products is that they're going to already buffer the water for you. But if you're going to use something like urea and your pHs are still up in that 8 range, I would probably recommend adding a buffer to the solution to try to bring your pH down at least to 7.5, maybe a little less. Good question. Other questions?
Quantitativo d'acqua?
We're going to talk about that in just a minute. Water volume? Yeah, we'll talk about that in just a minute. Okay, so another question that my student Chris had in his studies was how does the form of nitrogen that you use affect nutrient? Again, there are many different types of nitrogen sources out there, many different types of nitrogen forms that you can use to deliver nutrients. So there's really very little data in the scientific literature looking at some of these different nitrogen forms, and especially some of the ones that we see in specialty fertilizer products. Did we miss something? We look like we missed something here. Okay, about half of the text is not there. But okay, well, I can explain it to you. Basically, we did the same type of study that we did with just urea, but in this particular study, we had 6 different nitrogen forms. Okay, we had, there it is. We had urea, we had ammonium sulfate, we had potassium nitrate, and then we also had 2 amino acids glycine, proline, and then an organic acid, glutamic acid. The reason we chose these products was that these are common nitrogen forms in many of the specialty foliar products that are available in the drug market. Amino acids, okay? Amino acids are pretty common parts of those products. Again, we did this study on creeping bent grass. In this study, we only had one rate of nitrogen, a half a gram of nitrogen per meter squared. And in this case, we only sampled the tissue at 1 hour and 8 hours after applying the nitrogen. And again, all of these nitrogen sources were enriched, again, with this heavy form of nitrogen, this 15-EM nitrogen. So again, we can measure uptake very accurately in this particular study. Okay, so here are the results from that study. Basically, across the bottom here are our different nitrogen sources. So we have urea, potassium nitrate, ammonium sulfate, glycine, glutamic acid, and proline. And then this is, again, percent of uptake in terms of how much we applied. So 50% uptake or 100% uptake means that we got half of what we applied, or all of what we applied. And then this was sampled at 1 hour after treatment, and then again at 8 hours after treatment. Okay, so one of the things that we found in this study, and we saw this after multiple experiments, was that generally there was very little difference in the uptake efficiency of these products. And most of them were taken up very similarly by the turf when applied to the leaves. The one exception was, get the arrows down there, there we go, thank you, was potassium nitrate. Just about every study we did with potassium nitrate, it was always significantly less taken up than either the urea source, the ammonium source, or the amino acids. Okay? Usually it was down maybe 20% compared to the other sources. We also studied calcium nitrate as a nitrate source and found very similar results with calcium nitrate. Also, the uptake efficiency was lower for calcium nitrate. So what's the reason for that? Is there a scientific reason behind that? Well, there's some really good work done on cuticle layers in other crops. Okay, and one of the things that has been discovered is that in the cuticle, you have these small pores that are found throughout the cuticle. And that's the channels that nutrients move through. Okay, these are sometimes called transcuticular pores or ectodesmata. I know there's probably the translator's freaking out back there right now. What's an ectodesmata? I don't even know really. But one of the things they found about these pores is that they have charge. Okay, they're called polar pathways. It means they have a charge on it, and the charge is actually slightly negative. Okay, and so if you have a negative charge here, that means that things that are in a positive form, cations like ammonium or potassium, are going to be attracted to these pores because of magnetism and electrical magnetism. A neutral material like urea would have some attraction to it, but urea also may get converted into ammonium before it's taken up. So it's also very attractive to these pores. But then negatively charged ions like nitrate or phosphate are actually going to be repelled from these pores. And so we believe this is the scientific basis for why we saw reduced uptake efficiency with nitrate sources. Is that there's actually not an attraction for those nutrients to be taken up by the pores of that leaf. So from a practical standpoint, what does that mean to you? When you're looking at fertilizers to use for foliar fertilization, you probably don't want to use something that's going to have a high amount of anion charge here. Okay, whether we're talking about nitrogen or phosphorus or any other material, if that nutrient is going to be there primarily as an anion, it's probably not going to be taken up by the leaves as well as something that is going to have a positive charge on it like this. Okay. Then we'll come back to that topic here in just a second. All right, how to spray volume, your question, how much water, adjuvants, and tank mixing affect nitrogen uptake by foliar fertilization. Now, this was some work that was done by Bruce Branham and Shelby Hennon at the University of Illinois. So I stole their data from them to use here in this talk today, but it's good data because it's got some good practical information for you. So the first thing they looked at was spray volume. Okay, and so they looked at spray volumes ranging from 187 liters per hectare all the way up to 935 liters per hectare. What's your common spray volume in Italy for spraying fertilizers or pesticides? 800 to 1,000?
No,
He's mistaken?
Yeah. 500.
500 liters per hectare. So you're about right here in the middle. Okay, that's about, I think I'm trying to do gallons per acre here, because I think that's probably about 80 gallons per acre maybe. Or 100 gallons per acre?
100.
Okay, 100. Sorry, my metric conversion is not right.
Gallons for 1 hectare.
Yeah, it's possible. I'm talking about gallons per acre. You guys know liters per hectare? Okay, fine. That's why they're up there doing it right. As long as you know what it is, that's all that matters. All right, so what they found is that once you got over 500 liters per hectare, you actually started seeing a decline in uptake efficiency. And especially if you get out here to 700 or maybe 900 liters per hectare, you start seeing a significant decrease in uptake efficiency. Why is this happening? Well, most likely, once you get into these very high spray volumes, a lot of the solution probably just leaves the leaves and goes down into the soil. Now, again, I want to point out, just because it's not taken up by the leaves doesn't mean that it's not taken up by the plant. Okay? If you put out things at a high spray volume, your uptake efficiency through the leaves may be reduced, but you still are most likely going to get that nutrient absorbed by the roots. So again, it's not a loss, it's just the uptake efficiency of the leaves is going to go down. So again, if you're trying to get strictly foliar uptake, you probably want to be less than 500 liters per hectare to maximize uptake efficiency. Okay, what about the use of adjuvants, wetting agents, methylated seed oils, other types of adjuvants that you might use commonly for pesticide applications? What they found in this work was that in all cases, the use of an adjuvant usually helped uptake efficiency, okay, compared to the control. The control in this case was urea by itself. So again, using some type of adjuvant to help spread that liquid onto the leaves certainly is going to improve your uptake efficiency. And again, if you're using a formulated fertilizer product, especially a liquid product, most likely it has an adjuvant in it, okay, for that very reason. So again, you're going to get some advantage from having that type of product. What about tank mixing with other things? Again, I know American golf course superintendents are very different from Italian. The guys in America, they may have 15 products in the tank at any one time. Okay? Impossible. Yeah.
You don't have that many.
You don't have 15 products. That I believe. But again, it's very common for them to spray biostimulants and fungicides and insecticides and fertilizers and wetting agents that got all in the tank all the time. Okay? And basically what they found in this particular study, they looked at a biostimulant, a fungicide, just a spray indicator dye, the kitchen sink is when they put everything in the tank at one time, Primo, growth regulator. And what they found was that they didn't see any reduction in uptake efficiency by adding any of these products. So again, you're not going to lose your uptake efficiency by mixing your fertilizer with other products. Okay, so it's safe to do that mixing as long as they're compatible in the tank, that you don't have some type of mixing incompatibility that shouldn't affect your fertilizer uptake efficiency. Okay, so I want to finish here today just talking a little bit about some differences among foliar products. Okay, Now, there was a paper that, how many of you used Scanlon-Zonta? Anybody ever get a chance to meet Scanlon-Zonta? He was a very famous USGA agronomist that just passed away this last year. But this was a paper that he and a number of USGA agronomists wrote back in 2010. I encourage you to go look this paper up and take a read at it, because the central part of this paper was, does the grass know what kind of fertilizer you're spraying, okay, or applying to it? Does the grass know the difference? Focused on in that paper was that on the fertilizer you have a guaranteed analysis. Is it the same in Italy? You have to have a guaranteed analysis on the fertilizer? Okay, good. I assumed it was, but I wasn't quite sure. But the guaranteed analysis is going to tell you not only how much of the different components are in there, in this case 19% nitrogen, but it's going to tell you where that nitrogen came from. Okay? So in this case we have ammoniacal nitrogen, nitrate nitrogen, urea nitrogen, water-soluble organic nitrogen, and then it's got a little asterisk here that you can go down here and see that it's from polymethylene urea, methylene diurea, and liquid protein. I don't know what liquid protein is, but that's where some of this nitrogen came from. Okay? So the first thing that you want to be aware of is that, again, most of these products, again, they're good products. They're really good products. They have lots of different components in it, but they're not magical, okay? Where did the nitrogen come from? Well, a big chunk of it came from urea, okay? So it's the same thing as dissolving urea for that particular component of it, okay? So a lot of these products, you want to look at this very carefully, because you don't want to be spending money on something that you can basically find in a much lower cost form if it's primarily urea. Again, maybe there are things like amino acids, maybe there are biostimulants, wetting agents, other things in there that you're after. There's nothing wrong with that. But again, the nitrogen comes from the same sources no matter what the product is. Okay? Now, this particular product is pretty good that it's only got 2.5% nitrate nitrogen. So as we just learned, that's good. That's only a lower percentage that's in the nitrate form. Everything else is either ammoniacal or urea, or these more slowly available, maybe water-soluble organic nitrogen sources. Okay, so we were doing a little demonstration study a couple of years ago, one of our field days, where we looked at a bunch of different nitrogen source products, kind of showed how they performed, just did some demonstration plots. But one of the things that we really wanted to point out in this particular study to our superintendents was, again, how do you analyze it and what's the cost of these types of products, okay? And so what we did was we looked at a bunch of different products, and I apologize, there's a lot of information here, but we had basically, is there one more? Yeah. Okay, we had 3 simple nitrogen sources. We had ammonium sulfate, potassium nitrate, and urea. And then we had about 6 commercially available foliar fertilizer products. And we either put these out at either 0.63 grams of nitrogen per meter squared or 1.25 grams of nitrogen per meter squared. Or for the liquid products, we put them out at their recommended label rate, or we put them out at 1.25 grams of nitrogen per meter squared. Okay, so the point of this was to demonstrate the wide range of cost differences between foliar fertilizer products. Okay, and so if you look at these products, at this particular time, urea, and I don't know if this is still common here in Italy, maybe it's more expensive than this, it was to put out the higher rate of nitrogen as urea, it was about 13 euros per hectare at that rate. If you compare that to some of the other products at the same rate of nitrogen, some even as much as almost 2,000 euros per hectare to get the same amount of nitrogen. Now again, this product probably has a wetting agent in it, it probably has a biostimulant in it, it probably has micronutrients in it, maybe some other things that you're after. But if you're just after the nitrogen, That's a lot of money to pay for nitrogen. Okay? That's a lot of money to pay for nitrogen. So, if your goal is to get nitrogen or even phosphorus or potassium from your foliar fertilizer program, again, always look at all the options that are available. Because in some cases, an agricultural grade source of nitrogen like urea may save you hundreds or even thousands of euros for an application, okay, by using a lower grade product. Again, these are all good products. We've used all these products before and tested them before. They're all really good products. Nothing in the world wrong with them, but if you're just after the nitrogen, again, it's a very expensive way to apply nitrogen. Just nitrogen. Again, this is another little table that I just wanted to point out to you. Again, looking at the guaranteed analysis, again, these are some of the same products that you just saw, some different ones. Again, a lot of different foliar fertilizer products. Again, you just want to make sure you always see where did the nutrients come from. And again, in most cases, calcium nitrate, potassium nitrate, urea, ammonium nitrate, urea, urea, potassium nitrate, urea, ammonium phosphate, urea. Okay? So in most cases, the nitrogen forms that these products contain are probably going to be the same things that you can get from urea. Okay? So just remember that. It's a way that, especially on areas where you've got large surfaces to treat, using a product like urea is starting to save you a lot of money over some of the specialty products. Okay, so let me summarize this a little bit, and then we can maybe take time for a question or two. Again, when we're trying to put nutrients through the leaves of plants, we're talking about foliar fertilization, we're talking about low application rates. Okay, usually less than 1.25 grams per meter squared is going to probably be about your highest rate that you're going to get for foliar feeding. So again, if you have times of the year where you're trying to recover from damage or recover from aerification, that rate is probably not going to be high enough to really supply the plant with what it needs. So in those cases, root feeding is probably still a better option. We found in our research that we had very high uptake efficiency with foliar nitrogen compared to some of the studies that have been done on soil. We really didn't see any effective season of the year as long as the turf was actively growing, had good green foliage. We generally got the same amount of uptake efficiency. Sometimes it went up and down a little bit, but when we looked at it over 2 full seasons of research, we really never saw any trends that led us to believe that certain times of the year were better or worse with respect to foliar fertilization. Almost no volatilization occurs, so volatilization losses were very low. Again, spray volume seems to be one of the more important parameters from an application standpoint. Using lower spray volumes and the use of an adjuvant probably will improve your uptake efficiency, so that's something you should consider when you're putting together your tank mix. And again, always closely examine the fertilizers that you're buying and look at the guaranteed analysis. Okay, where did that fertilizer come from, and is it something that I can put together myself? Is it something that I can actually make a similar product to use for foliar fertilization or other applications and save myself and save the course a little bit of money? Okay, so this is Chia Chingali. And again, I thank you for having me here in Italy. I'm going to be here for the next 5 months. So if you have questions or if you want me to come visit your golf course, I'd be happy to do it. So just let me know. And I've got some cards, and this is my email address. Feel free
Allora, si è visto dalla sua relazione che la fertilizzazione foliare è molto diffusa negli Stati Uniti. Allora io volevo chiedere questo: in Italia ci sono delle problematiche anche per ragioni logistiche di lavoro nei campi da golf. Quindi la distribuzione di fertilizzanti liquidi nel complesso delle lavorazioni del golf molto spesso interferisce con quello che è il gioco, cioè il campo da golf a 18 buche. Se fa una fertilizzazione liquida, non dico una volta al giorno, una volta alla settimana, ha dei problemi di macchine che passano durante il gioco, anche perché oggigiorno in Italia molti campi da golf tendono a non avere più il giorno di chiusura del campo, ma il campo lavora 7 giorni su 7. Quindi molte volte è difficile distribuire il prodotto liquido quando la gente gioca, cioè disturba l'insapurenza della gente. Volevo chiedere come il giorno forse hanno un maximo di lavoro
Okay, so if I understand the question, the issue is that you have a hard time applying products because of the amount of golfers and players that you have out there. You know, it's a problem. It's a problem everywhere. Certain courses in the United States have the same problem. Generally, what most golf courses will do to try to get around that is that they may make applications. If they have an 18-hole course, then they would go out in the mornings and make applications to the second nine, holes 10 through 18, early in the morning. So that would give them maybe a 2 or 3 hour window before players reach the 10th hole. And then in the afternoon, once the last groups of golfers get through the 9th hole, then they can go out and make treatments late in the afternoon to try to, you know, get behind the golfers. Ideally, they would go out very early in the morning, and I see more superintendents now with really massive light systems. Sometimes they're out there at 4 o'clock in the morning, mowing, spraying. I mean, they do everything in the dark. Sono sui volumi di applicazione fondamentalmente un modo diverso di lavorare al suolo. Fertigation is just a different way to bring nutrients to the soil, or okay, that's an excellent question, one that I sometimes discuss in this seminar. Fertigation is the application of fertilizer through the irrigation system. So we're dissolving the fertilizer into a large tank and then pumping it through the irrigation system. Typically, the volume of water that nutrient is being applied in, back to the graph where we looked at water volume, the water volume is going to be so high that probably foliar uptake is relatively small. You can get some foliar uptake, and probably, I don't know what the number is. I've never seen any research to see how much is taken up by the leaves versus the soil, but probably most of that is going into the soil and being taken up by the roots. You know, in the States, I would say fertigation is not really popular on golf courses, mainly because the irrigation systems are so inefficient at applying water that it's very difficult to get uniform application. Maybe your irrigation system is better in Italy, but if you look at the efficiency of the irrigation system, you have twice as much water going out here as you do here, and that means twice as much fertilizer. So it's used, but I would say it's not used as much as probably some people would think. Okay.
Sente? Dottor Richardson, nella sua presentazione lei ha parlato di una equivalenza tra i sali e gli ingredienti, componenti di questi prodotti, dicendo che facendo quella tabella comparativa dove analizzava l'urea con altri prodotti a base di urea e dicendo ma perché non prendete solo l'urea? Molto semplifico, molto. In realtà, almeno da noi in Europa, noi abbiamo avuto grossi problemi, anche noi sperimentalmente, quando siamo andati a procurarci delle uree agricole, le quali poi miscelate in acqua, in soluzione, hanno provocato una forte fitotossicità sull'erba. E molto spesso i viticoltori che utilizzano l'urea agricola dissolta in acqua e fanno i trattamenti stanno molto attenti sulle quantità e sui dosaggi, proprio perché è successo altre volte di dover bruciare le superfici del prato proprio perché la materia originale non era di alta qualità, soprattutto per il tasso di piumeto e per l'alto indice di salinità di questi componenti. Volevo una sua riflessione al riguardo.
Okay, thank you for that question. It's a good question. Certainly, if you use urea, especially if you use some of the ammonium sources, ammonium nitrate especially, ammonium sulfate, all of those products are going to have a higher potential for phytotoxicity and burn than probably some of the formulated products. Why is that? Again, probably you don't have a buffered system. You don't have enough buffering agent in there, and it can cause some burn. So it is a potential problem. So if you're going to use urea as a foliar source, you want to make sure it's a high quality urea, that it's not something out of a train car that you just picked up somewhere, but that you use a high quality source. And again, you've got to just watch the rates. I think as long as you're under that 1.25 grams per meter squared of nitrogen, we've never seen problems with urea. Maybe our urea sources are different than you have in your business. I don't know that, but we've never seen burn potential with urea at those rates or lower. And again, some of the formula products, some of the formulated products that are out there, when you look at the nitrogen application rate, a lot of times the nitrogen application rate is not 1.25 grams of nitrogen, but maybe half of that or less. And if you sprayed urea at that rate, my guess is you would see it burn. So, but again, with any product, it doesn't matter whether we're talking about nitrogen or a surfactant or anything, just like in the States, I always recommend superintendents, don't spray all 18 greens until you've at least tried it a little bit on your practice green or somewhere else to make sure for your water, your application method, whatever, it works in your system. So, but certainly with the soluble materials, there is more potential for burn. Ammonium sulfate and ammonium nitrate, even more, they have a higher salt index than urea does. So you got to be careful with it. Get my translation. It's pretty good back there, actually. That can be written temperature sono molto importanti quando abbiamo questo prodotto di acqua, perché se noi, io parlo della mia esperienza, in Sardegna noi abbiamo 22-23 gradi alle 4, alle 5 della mattina, non posso fare questi gradi. This is with the creek and pit dress? Creek and pit dress? Well, yeah, all I can say is our temperatures in Arkansas are at least that warm, maybe warmer at 7 o'clock in the morning or 6 o'clock in the morning. So we haven't seen any problems with high temperatures causing more phytotoxicity if they're sprayed early in the morning. Again, I think it's the best time to do this because you have more moisture in the system, so that the solution can stay on the leaves a little bit longer for uptake. But as long as you're getting those things out as early in the morning as possible, I think by the time you reach the real heat of the day, most of the uptake has occurred and you shouldn't see any problems. Now, I wouldn't recommend going out in the middle of the afternoon and spraying these products. I mean, the potential for burn would be very, very high.
And how close to the debris go in?
Say that again?
Debris. When debris goes on the course.
I don't think it's a problem. I mean, you shouldn't. I mean, I don't know. Maybe have you seen people's footprints or tracking from applications of fertilizer? I haven't really seen that, but it's. I mean, I guess it's possible if they were out there within a few minutes after spraying. I mean, yeah, I would think if you had maybe a half an hour or an hour, it's probably no problem.
Basically, the dye or some problem.
The iron? Yeah, I can see iron maybe causing some potential problems. Yeah. So you get some tracking with for players. Yeah, I can see that making a potential problem. But, I think you still have to, if you want to use that type of product, you have to just probably spray it and live with the consequences.
Thank you, Mike.
Right, thank you.
Il professor Richardson sarà qua con noi anche domani mattina, quindi se poi abbiamo altre domande, possiamo fare domani. Thank you so much.